Okay, hello everyone. We are just waiting for everybody to come into the room. And once people are in the room, we will get started. So I'll just give it a few minutes. Again, welcome everybody. Some more people are coming into the webinar, so we'll just give it another minute before we get started. All right, I will start with introducing Dr. Wang. But first of all, thank you to another webinar in the Music for Pain Research Network webinar series. We are excited to have Dr. Dan Wang today here with us. Dr. Wang is a postdoctoral research fellow in the Human Brain Function Lab within the Department of Neurosurgery at the University of Virginia School of Medicine. Dr. Wang has extensive research experience in pain management, and she is also a clinically trained physical therapist. And her research focuses on elucidating brain mechanisms underlying pain modulation, and also on identifying neurophysiological biomarkers to advance personalized pain management. And without further ado, Dr. Wang, I'm going to turn it over to you. Thank you so much for agreeing to present today. Dr. Wang will have about half an hour, or will present for about half an hour or a little more, and then we would be happy to answer any questions that you may have. I would like to ask you to please put your questions in the Q&A section of the webinar, because that's what we will be monitoring to make sure that all of the questions get answered. If you have any technical difficulties hearing us or whatever, feel free to put that in the chat. But if you could put your actual questions in the Q&A, that would be great. And so, Dr. Wang, over to you, please.
Okay. Thank you so much for the introduction. I'm very happy and glad to be here and have the opportunity to share my recent work with you all today. So this project is about EEG and how positive affect can reduce pain. So specifically, we're looking at how alpha power in the brain activity during music, listening, and painful stimulation to better understand the underlying music-induced analgesia in patients with knee osteoarthritis and versus healthy controls. So pain is a multidimensional experience shaped by more than sensory inputs. Prior experience, attention, expectation, emotion, all can influence how incoming noxious signal are transmitted, interpreted, either amplified or dampened through bottom-up and top-down modulatory pathways. So taken together, pain is this integration really highlights pain is a product of integration of sensory, cognitive, and emotional processes. A study conducted by Rudy and his colleagues in 2008 really demonstrate emotions strongly shape how people experience pain. When participants view negative image, they tend to report higher pain, demonstrate multiple pain-related physiological responses, also increased. Neutral image show little change. When participants view positive image, especially those very pleasant ones, they tend to report significant lower pain and dampened multiple pain-related physiological responses, including nociceptive flexion reflex, skin conductance, and heart rate. A recent meta-analysis conducted by Wang in 2020 summarized the findings from multiple studies investigating positive affect interventions on pain reduction. So each line of it represents one study, and then the effects as a majority of studies cover 0, indicates there's no significant effects of positive affect intervention pain reduction. So on the diamond at the bottom indicate the effects are very small. And so this meta-analysis really suggests that the effect of positive affect intervention on pain reduction are modest and inconsistent across studies. So the meta-analysis highlight the urgent need for personalized positive affect intervention aligned with their underlying mechanisms for better treatment outcomes in patients with chronic pain. So a PET study conducted by Blood and Zadro in 2001 on the left hand examine what happens in the brain when people experience pleasant pleasure, intense pleasure from music. So participants listen to their favorite music. What they found is as intensity of the pleasurable sensation increase, activity in the brain also changed in areas involved in the reward and emotion arousal systems, such as ventral striatum, ventral medial prefrontal cortex, ACC, amygdala, and occipitofrontal cortex. Another fMRI study conducted by Dobek in 2014, wherein participants undergoing a controlled painful stimulation while either listening to their favorite music or in silence. What they found is when music was played alone when pain was delivered alone without music, there are key parts of brain areas involved in pain processing. Pathways were activated. Interestingly, when music was added, additional brain areas were also activated, involved in areas such as involved in emotion, motivation, and pleasure, including limbic and frontal cortex. And more importantly, what they found is when music was added on, some key parts of the brain involved in dependent pain modulation pathways also were activated, such as dorsolateral prefrontal cortex, PAG and RVM. So this imaging analysis really suggests that music-induced analgesia may involve both reward and emotion attention pathways and also some top-down pain inhibitory pathways. However, neurooscillatory activity underlying music-induced analgesia were poorly understood. So we don't really know whether the mechanism differ between patients with chronic pain versus healthy control. So compared to neuroimaging techniques, EEG has several methodological advantages. For instance, it provides very high temporal resolution, so it can track brain activity on the millisecond level. This is very special, useful and helpful to study rapid brain processes, especially pain and emotion interactions in this case. Brain activity, particularly in alpha band in the frequency range between 8 to 12 hertz, has been widely investigated in the literature because it has been thought to reflect cortical inhibitory control, attentional gating, and thalamocortical sensory gating mechanisms. Furthermore, studies conducted by Linas and Sarthin investigating resting state EEG brain activity, and they demonstrate there's a profound resting state EEG characteristics differences between patients and healthy controls. So what the figure demonstrates here is patients with neurological disorders or psychological disorders, they show some abnormal spectral power compared to healthy controls. Particularly, patients tend to have abnormal increase oscillatory activity and slowing oscillatory activity compared to healthy controls. So However, what we don't know is how alpha power would respond when positive affect stimuli are presented concurrently with pain. So this study is specifically looking at from this perspective. So to induce affective pain modulation in our study, we use music as a affective intervention. Compared to other affective intervention tools such as auditory or images, music serves as several advantages because it can be a personalized affective intervention tool. It has high emotional salience. It has strong ability to evoke autobiographic memories. It also shows robust analgesic effects. And we also will present 3 types of music to participants in this study. Before their visit to the study, we select and have them select the music and prepare the music for them. So for the neutral music, we select 4 separate 60-second clips of ambient noise. For negative music, we select 4 60-second negative music clips that has been widely used in the literature and also well established. Particularly for positive music, we have participants select their favorite songs and indicate what are the segments they prefer the most. And then we trim those preferred segments into 60-second clips. For the experimental pain, we use MADOC to deliver experimental heat pain. For each participant, the temperature was individually calibrated so that it produced the pain ratings of 50 out of 100. And then we use 32-channel EEG recording system to record their brain activity. And then we also filter the EEG signal from the frequency between 0.1 to 50 Hertz to remove high frequency noises. Each music listening condition lasts about 1 minute. So we also visually inspect their movement or muscle activity related artifacts and noises. So after that, artifact-free signals were segmented into approximately 30 seconds epochs for data analysis. And during the study visit, other participants underwent the affective pain modulation task while also underwent EEG recordings. So we present them 3 music, neutral music, negative music, and positive music. All the music were played through a speaker nearby the participant. All the music were volume controlled across each music condition. And all the music conditions were counterbalanced and randomized across participants. So each music will be repeated four times, which means indicates figure over here, 4 trials, and each trial consists of 2 phases, music only phase and music plus pain phase. During the music only phase, we'll play 30 seconds music only, and after that, we apply the heat pain to the participants' abdominal ventral forearm for 20 seconds. So the heat pain stimulus were individually calibrated to produce the moderate pain of 50. So at the end of the painful stimulation, the music continue for actual 5 to 10 seconds before stopping. And after that, the participant rate their pain intensity and pain unpleasantness for pain and using 0 to 100 of AS. Also, they're gonna rate their arousal and positive emotion and negative emotion for the music itself using 1 to 9 scale. 1 indicates the lowest level and 9 indicates the highest level. So here are the participant characteristics for the study we have enrolled. So healthy, control, and neuro patients have similar number of participants. It's about like 50-ish for each group. Neuro patients are much older than healthy controls. It's mainly due to their wise, and both groups have similar percentage of female participants, and NEOA patients have larger percentage of Caucasian compared to healthy controls. The thermal temperature used to deliver heat pain was similar across between groups. And as expected, NEOA patients report higher pain severity and pain interference compared to healthy controls. And then NEOA patients report slightly higher arousal in general compared to healthy controls. Their positive and negative emotions are pretty similar between groups. We also check the music manipulation to see whether we successfully induce the affective stimuli. So from the figure A, both NEOA patients and healthy control report while listening to negative and positive music, they report higher arousal compared to when listening to neutral music. Similarly, both groups report higher positive emotion while listening to positive music and higher negative emotion while listening to negative music. So this finding suggests our music valence can serve as an affective stimuli in this group, in this study. And for the specific statistic plan, we mainly use linear mixed effects modeling to analyze behavior data and also neurophysiological data. For the behavior data, we focus on pain intensity and also pain unpleasantness ratings to investigate the difference between groups and also music valence conditions. And then random effects were specified for participants and also for music valence to account for within subject variability and also music valence variance. We're also adjusting potential confounders, such as age, sex, positive and negative affect, if any of them show significant associations with outcomes. Similarly, for the neurophysiological data, we mainly investigate alpha power. For the group, we're first modeling a group comparison model to investigate the alpha power between groups and across music valence and also across between music only versus music plus pain phase. Well, random effects also were specified for participants and also for electrode size to account for within subject variability and also account for topographical dependence across electrodes. And then after group comparison, we also zoom in within group difference. So we also investigated alpha power for each group to investigate whether there is different patterns across music conditions and also between phases. Similarly, random effects were specified for participants and also for electrode size. For all the models, we also adjusting for potential confounders, age, sex, arousal level, and their music-induced emotions if any of them show significant associations with outcomes. And here is our preliminary results on the figure A, demonstrate the preliminary results of pain intensity. So for healthy controls, as you can tell, positive music induce lower pain compared to neutral music, and negative music induce higher pain compared to neutral music. I think this finding suggests there is a global distraction effect of music, particularly during positive music for healthy controls. But the fact that negative music induce higher pain indicates the effects of the condition is beyond distraction. It's actually music valence itself plays an important role in the affective pain modulation. For the NEOA, we see both positive music and negative music induce lower pain compared to neutral music. That also demonstrate there's a global distraction effect of music. The fact that negative music also induce lower pain compared to healthy neutral music in NEOA patients actually indicate there is a disrupted there's disrupted affective pain modulation in NEOA patients. And also by looking at the data, the positive music-induced pain reduction compared to neutral music in NEOA patients is a little smaller than healthy control, although it does not reach significance, but it really suggests NEOA patients may have impaired reward processing under positive music compared to healthy controls. And figure B is pain unpleasantness ratings. Is pain unpleasantness demonstrates similar patterns, like as pain intensity between groups and also across music conditions. Here is the power spectral density figures. It's average by group across music conditions between music only and music plus pain phase. It shows the spectral shape are similar across condition between groups, but with some differences between groups. And also you can tell variations across music conditions. And here are the preliminary results of the specific resting state alpha power were investigated. So this results from the group comparison modeling, and there's a significant three-way interactions between group music only versus music plus pain phase and music valence conditions after adjusting for their arousal and induced emotion level. There's still significant interaction here, indicates alpha power changes from music only to music plus pain phase differ between patients and healthy control as a function of music valence conditions. Because we see the group differences and music valence conditions also differ, particularly NEOA patients demonstrate larger reduction, alpha suppression from music only to music plus pain phase, depending on the music valence conditions compared to healthy controls. So we also do more analysis to zoom in each group for healthy controls on the left side. On the left hand, those are the results after adjusting for their arousal and music-induced emotions. For healthy controls, the alpha power, when they're listened to neutral music and negative music, there is a significant alpha suppression from music only to music plus pain phase. However, when they listen to positive music, you can see the alpha, there is no significant difference between music only and music plus pain phase. So it indicates positive music in healthy control actually buffer against alpha suppression, which support healthy control maintain their cortical, thalamocortical gating, sensory gating. When we're looking at the NEOA patients, when they listen to neutral music and negative music, they both show significant alpha suppression from music only to music plus pain phase. However, different with healthy controls, NEOA patients also show a alpha suppression from music only to music plus pain phase. It actually indicates NEOA patients has impaired top-down inhibitory controls because when the nociceptive signal come in, their brain is failed to attenuate alpha suppression. So the fact that both healthy controls and NEOA patients experience less pain when to music case that NEOA patients may engage compensatory strategies to achieve analgesia. Not like healthy control, they may achieve analgesia through the thalamocortical sensory gating mechanisms. However, NEOA patients may engage some other mechanisms such as some downstream evaluative systems, such as dopaminergic reward loops or prefrontal cognitive evaluation. So those are the preliminary data we have so far. I'm also planning to do some more statistical analysis to specifically looking at what specific regions of brain contribute more to the differences or to the patterns we observe between music conditions and across music conditions and between group. I'm also going to looking at the peak alpha frequency and to see whether there's also different patterns regarding their music conditions and between groups. Also, I'm going to looking at a real baseline resting state power between groups before we apply any music to them. So briefly, in conclusion, a music-based positive affective pain modulation task in this study demonstrate a reliable analgesic effects of positive meaningful music. Newer patients experience pain relief from positive music, and then chronic pain demonstrate a neural processing shifts from thalamocortical sensory gating to increased desynchronization. And then we also demonstrate music may serve as a therapeutic tool and also a probe to investigate thalamocortical gating dysfunction in chronic pain patients. And also a brief interpretation summary. We found pain modulation depends on emotional valence. Only positive music produce consistent analgesia in both healthy controls and newer patients. In healthy controls, positive music preserve alpha power, supporting they have maintaining thalamocortical sensory gating. However, in newer patients, they fail to attain depression, indicating there's impaired top-down inhibition. So furthermore, other findings may suggest chronic pain patients achieve analgesia through a compensatory pathways, some more like downstream evaluating system and cognitive controls, rather than early thalamocortical sensory gating like healthy controls. Lastly, I would like to thank the Fan Lab and the Liu Lab for their support, and especially I really want to thank Dr. Fan and Dr. Liu for their mentorship and support, and then all those insightful discussion to help with the study. All the lab member for their contribution to the work. Thank you all for the listening.
Thank you so much, Dr. Wang, for presenting this very interesting research. I see that we have one question posted so far, so please, folks, feel free to add. Oh, other questions are coming in. Very good. Feel free to add more questions in the Q&A. If you were not here at the beginning when I asked everybody to please put your questions in the Q&A, not in the chat, I would greatly appreciate that. Helps me to keep monitoring what we've answered and what we still have to address. So Dr. Wang, here is a first question from Jonathan Tang. He thanks you for your presentation, and he asked if you could please clarify what the negative music refers to. And I had the same question. Could you say a little bit more? I know it was established in the literature, but what was this negative music?
What the negative music we used in the study? Is that the question?
Yeah. Mm-hmm.
Okay. So the negative music is the music I think we used that has been widely used in the literature, established. It just,
But what was it? What type of music was it?
So I personally did not design the negative music. So I don't know much of the details, but what I learned is the negative music is general utilized in the literature. Like we listen to, majority of people would think that's negative. That would not be sound pleasant. That's what I learned.
Yeah, and I just see that Dr. Finan let me know that this was songs chosen from Dr. Mathieu Roy's prior work. It was 4 clips of heavy metalish kind of music, and I know that in Dr. Roy's work they or the music that he used was indeed had been verified with lots of people, lots of participants in prior studies that, you know, across the board people would rate that music as negative sounding or evoking negative type of emotions. But important to realize is, of course, that not all people find heavy metal music negative, right? So, and Dr. Finan just responded that it is certainly something that they are working on to refine for a future iteration of this study. So very good question, Dr. Tang. Okay, another question from Ting Ting. Could you please describe more of how you select, oh, it's the same question, sorry, how you select the music for the negative music condition. Okay, so that has been answered. While people add some other questions, I have a question, just a methodological question, because one goal of these webinars is to let people know about cutting edge research, but also to help people become more aware or help them consider important aspects of designing a study like this. So a kind of general question I have is, how did you decide what the length of the music exposure should be before the pain stimulus is applied? So in your study it was 30 seconds. Could you talk a little bit more about why 30 seconds, why not a minute, or why not 10 seconds?
I think well, again, I actually did not participate too much on the study design itself. My understanding for the 30 seconds is it's not too long, it's not too short. It's give this parties enough time to immerse, prepare them mentally, immerse them into the music they're exposed to. Also, we also record their EEG recordings, they're including the EEG preparations, and then play the music, 3 music, and then each music 4 trials. The whole study design is actually quite long, so we don't want to play music too long to hold the participant too long. I think considering all those factors together, 30 seconds works well.
Yep. And actually, I would refer people who are interested more in how to select your music stimuli, how long they should be, to go to our website where we list all the recordings of past webinars. And one webinar was specifically focused on selecting music in laboratory experiments like this one, as well as in clinical studies. And there the length of stimuli considerations is addressed, and indeed one of the considerations, of course, in these kind of studies where you have repeated exposures, that you can't have that experiment become so long, because that would of course be a major confounder as well. All right, here is a few questions from Kieran Kang. Regarding the positive music stimuli, I understand that you use participants' preferred music. Given that preferred music can widely vary in genre, mode, tempo, and other acoustic features, how did you account for the variability in musical characteristics that then might differentially influence EEG activity? So did you control in any way for or analyze the specific acoustic parameters? So for example, some patients may have chosen music that would be considered quite relaxing, while other people might choose music that is very uplifting and fast, has a fast tempo.
For positive music, we have some participants select their favorite songs. I think as long as they consider that as a favorite song, we would acknowledge and use the song they picked up. And then for the characteristic wise, specifically for music itself, we did not really assess or jazz or more loud noises or classic music. We did not compare that characteristic wise of music itself, but we actually check the music modulation if we successfully induce positive emotion or negative emotion. And for the data it demonstrates, it really shows when we play positive music, both of them report higher positive emotion. I think the goal is whatever favorite music we choose, we want to induce their positive emotion.
Yeah,
So I think that is a goal.
yeah. That makes sense. And related to that particular question and answer, we So we have a mechanism working group that spans across the different music networks that are being funded by NIH. And we recently completed a scoping review looking at mechanistic research like this. And we learned a lot during that scoping review in terms of specific challenges in designing these types of studies. And some of these questions actually point to some of these challenges, or at least things that people should consider. And we're currently writing a methodological manuscript that will offer a lot of advice, considerations, guidance around design of mechanistic studies, and also specifically about the selection of music. And the selection of music and the music stimuli is of course going to be very closely tied to the target mechanism. So the fact that here the target mechanism is positive affect, that is what is being controlled for in terms of the music selection. So it's of course not possible to control for 101 elements, right, in a study like this. So the most important aspect to control for here, or to make sure that you have, that you control for, is to make sure that the music indeed evokes positive affect in these participants, which clearly, as you demonstrated, you were able to do.
Mm-hmm.
Okay, another question that we have is, did you examine any correlations between behavioral outcomes like pain intensity and EEG neurophysiological measures? It would be very interested to know whether changes in brain activity were associated with the changes in the subjective or the clinical outcomes.
Yeah, I do examine based on the preliminary results, the alpha suppression in each condition within each cohort where their pain intensity changes and pain unpleasantness. Focusing on alpha power. I did not so far observe a significant correlations yet, but I plan to do more correlations in some other ways, specifically looking at specific electrodes like some other sensory uh, cortex level or some other regions of the brain. Yeah.
Okay, I'm just reading here another question. Okay, I'll read the question. I think that you addressed this in your presentation, but maybe it's good to reiterate it. Somebody wrote, I cannot remember if you specified this in your presentation, but I was wondering if you assessed people's emotional responses to the different types of music. So did they have to actually report feeling positive emotions through the positive music and so on? And the person says, I'm asking because I'm asking how you might probably disentangle the bidirectional effects of emotion and pain. So higher positive emotions may lead to lower pain perception, but lower pain perception may also lead to higher positive emotions.
I think that's the goal, right? The goal is to use first of all, we do assess their at the end of the music and pain, we ask them to rate, not just the rate, including ratings of pain and unpleasantness. We also ask them to rate their positive emotion, negative emotion, and arousal to each music condition. So we do assess it. And those are the results demonstrate the music serve as affective stimuli is supposed to. And we actually the study design is to using the positive music to evoke their positive affect and to see how the positive, because every single participant undergo the same level of pain. They all undergo the pain 50 calibrated individually. So we really want to use the music to evoke different affect to see how the affect can modulate their pain. This is the design we're trying to achieve. So this, if they're interact with each other, that's why we also record the EEG brain activity, trying to understand underlying mechanisms. This is the whole study goal. Yeah.
Okay, and somebody is saying there's something blocking the screen. That might be me looking at the Q&A questions. It
Okay.
probably goes away. Actually, there's still something else blocking the screen, and I don't. Oh, there it is. It's going away. Any other questions that people have or comments? They don't have to be only questions. Well, people think of questions. I have another one, and again, it's just from a methodological perspective. So I see that in your analyses, you said that you, of course, took age into account as a potential confounder. But is there a reason from a scientific perspective when you choose or select your healthy controls, would there potentially be an advantage of age matching your healthy controls because
Yeah.
now you had a huge age difference, right?
Yeah. Um, Certainly, right now the healthy control is too young compared to knee osteoarthritis patients. Um, I think it's the best we can if we can do the age matched healthy controls. That certainly would eliminate aging effects in the study design. But since we're in the university settings and a lot of healthy controls are university students, it's very convenient for them to come to the lab and collect all the data from them. Yeah, so um, that's how we end up being collecting so many young adults. But it certainly would help us to understand deeply if we do the age matched healthy controls. But we try our best because we statistically adjusting for the age uh, in the models. Hopefully that could help eliminate some aging effects in the results.
Yeah. Any other questions? I have a question related to the question that was asked just a little while ago about whether you tested whether people experience positive emotions or negative emotions, with the specific types of music. So I think if I understand when you were explaining the design, you tested that after the experiment. They had to rate, the emotional valence
Yeah.
connected to each type of music. Did you also assess their emotional response to these music stimuli before the experiment, before the start of the experiment?
That I'm not sure because I did not involve much on the data collection part.
Okay.
They may have the data, but right now data I analyzed, I haven't looked into the details about whether they
Yeah,
have.
I see that Dr. Finan says
Uh,
it didn't. I don't know, Dr. Finan, if I can actually unmute you. Probably not in a webinar. But here is why I'm asking, related to the question that was posed. So the question was, how do we know that it is the positive affect that is
mm,
that is the mediator, that is reducing the pain or affecting the alpha power versus could there potentially be a scenario where the music improves pain or reduces pain intensity for another reason? Maybe it is attentional affect or something else. And because the music reduces pain more, um, that's why people now say that they feel that they feel good listening to that music. Does that make sense? So it's maybe
mm.
because the music reduces the pain that therefore now they say, oh yeah, that was positive music.
Yeah, and also we also think about like probably I think the pain reduction from distraction attention is inherent. You cannot remove that part because no matter what you engage in, there's attention, you know, as distraction involved. But we assess their arousal level from music conditions, and then you can tell both positive and negative music induce similar level of arousal, which means they draw their similar level of attention. But the fact that in healthy controls, positive music reduce pain significantly more than negative music, actually negative music induce higher pain, I think it really reflect that it's more than attention, more than attention drawing or more than distraction. It's some music valence itself play a role in the effective pain modulation. And also we analyze all the data by adjusting for their arousal level. So I feel like the pain reduction under positive music is more than distraction and attention. It's music valence play important role to activating the affective pain modulation system.
Yeah, and I don't know if people can actually all see the chat. I assume you do, but I'll read Dr. Feinen's response just to make sure. So he responded to the question the same as you just did, Dr. Wang, that you were able to control for the arousal, and so the arousal itself cannot explain the findings. However, he does note that arousal is not quite the same as distraction, of course, and so it doesn't rule out that distraction in and of itself might not have played a role here, but still that valence is the best inference right here for the results that you showed. Yeah, so those are interesting things to consider, right, when you look at results like this, and it's always good to continue to critically ask these types of questions. And Dr. Tang, Jonathan Tang actually said, yeah, that's exactly what he was wondering, whether the valence was also measured at baseline. Any other questions? If not, I would like to thank you, Dr. Wang, for your wonderful presentation and this very exciting research. We look forward to seeing much more of this, and I was actually particularly thrilled that you were presenting this, because so much of this research to date has been only in healthy volunteers with experimentally induced pain, and there are of course other studies with people with chronic pain conditions, but it's so important that we begin to do more research like this with people with chronic pain, because as you clearly demonstrated, there are some clear differences here. And so I really want to thank you for your work, and I want to thank you for your willingness to present to us today.
Thank you for the opportunity to share my work.
Of course. Thank you so much, everyone. Thank you for attending. Dr. Wang, do you actually have a slide of our next presentation? If not, I think, let me just quickly, as people are still here, let you know that our next webinar will be on the neural correlates of music-induced hypoalgesia. It will be held on March 30th, and it will be Dr. Elise Desbarats, who is a PhD student in Dr. Mathieu Roy's lab at McGill University. She will come and present on that for us. So you can go to our website, as always, find information about our webinars there and register for the webinar. So we hope to see you next month for another exciting webinar. Thank you so much, Dr. Wang.
Thank you. Thank you so much all.
Bye-bye.